Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about how to calculate lambda max using Woodward and Fisher rule, and there we have learned only one of the system, which is a Dine system. What do you mean by the Dine system, or how do you define the Dine system? Dine system is nothing but as a conjugated system, means alternative double bonds are present, means the two double bonds are separated by a single bond, are termed as a Dine system, and that Dine system may be present in the ring or maybe as in a acyclic compound. And how to calculate that? What are the base value used for Dine system? Only one base value we are considering 215 nanometer. Second one, generally as a exocyclic double bond, we adding 5 nanometer in it. Third one is a Homo annular system, and as we know that Homo annular system means both the double bonds are present in the same molecule, and that type of the system are generally termed as Homo annular system. And then extended conjugated, instead of Dine system, if there is a extra double bond is present and in a conjugation, then it is considered to be a conjugated system, and then there we are adding as a 30 nanometer in it. So in this way we have discussed, I think near about as a 15 example we have solved based on it, and I hope by observing those 15 examples you can able to solve any type of the example on the depend upon the Dine system. I think today we are going to learn the second system, which is known as a Enone system. This is a B, we can call it as a Enone system. Two system we are going to learn. This is a Enone system. Enone system. And how do you recognize? What do you mean by the Enone system? Let me draw here one structure. So here double bond, then there will be again double bond, then here is the oxygen atom, and here I am putting as a Z. Observe this structure carefully. What do you see over here? This is a carbonyl group. Here Z is considered to be any group. Depending upon that, we will see later on. But the Enone system, look at this part only: carbon-carbon double bond, single bond, and the carbonyl group. So that type of the system is known as a Enone system. If then you can call it as a, this is a carbonyl group, adjacent carbon atom is termed as alpha, and next carbon atom is termed as a beta. Then alpha beta unsaturated carbonyl compound, maybe as aldehyde or ketone, are known as Enone system. Remember here, this is the look at this structure carefully. Only this part of this compound you will see here: carbon carbon double bond, single bond, and the carbonyl group. Such kind of the system is known as Enone system. Understood? And now look at carbon carbon double bond and double bond. Most of the students get confused. Here Dine system and Enone system. No, don't consider. Only see this is the part, this is a Enone system, and this is the extra double bond present here, and here also we are going to use, which is I already at the beginning I already told you that is a short form which I am prepared, that is a base this value. So that are the 5 letter, and if you follow this, then you can able to solve the problem based on it. Now here alpha, beta, you can call it as a gamma, delta and so on, omega and so on. So this is known as this part only known as a unknown system. Now once you identify the unknown system, what is our first thing to write the what we can call it as a base values. Remember, here are 3 base values, base value, and base value. Suppose Z is equal to, here if 215 nanometer, if Z is equal to alkyl group or ring residue, or what we can call it, Z is equal to alkyl group or 6-membered ring, then you can consider as a 215 nanometer is a base value for this is a first. And suppose if you have what we can call it as a base value 202 nanometer, if there is a 5-membered ring is present, 5-membered, EM stand for as a 5-membered ring is present, then you can take as a what we can call it as a 215 nanometer, and third one we can call it 1, 2 and 3 base values, or don't count it is 1, 2, but here 207 nanometer, if Z is equal to hydrogen atom, means aldehyde, then you can consider to be as a 207 is a base value. If you remember these 3 values, then you can able to solve the problem. If you remember as a Dine system, there is only one base value which is 215. Here also as a 215 nanometer, when to consider when there is a alkyl group or the ring residue, or if there is a ring is present and that ring must involve 6-membered ring, then you can take it as a base value 250 nanometer is in that example. Now when to take 202 nanometer as a base value, if there is a 5-membered ring, if that unknown system involve 5-membered ring, then you can take 202 nanometer is a base value. If Z is a hydrogen atom, is that becomes as a aldehyde, and as we know that aldehyde are always present at the end of the carbon chain, and therefore then if such a type of the aldehyde unknown systems are present, then you can take as what we can call it as a base value is a 207 nanometer. That's it. So this is the way. Now this is the first one. There are the 3 values you should consider. Second one, as we know that second one is a exocyclic double bond. E stand for exocyclic double bond. Exocyclic double bond. Then you can consider as a 5 nanometer. How do you know the exocyclic double bond? Let us see over here. Here is a double bond. One double bond is here. So this is the case. If you observe this structure carefully, what do you see over here? Is this molecule contain unknown system or Dine system? Look at here. This compound, suppose this is a carbon-carbon, a carbonyl group, single bond and double bond. and this system is a enone system. Remember here, it is a enone system because it is alpha beta unsaturated carbonyl compound, and now here a ring residue means carbonyl group, means it is a 6-membered ring, and therefore the base value should be considered as a 250 nanometer. And now there, what is that? Exocyclic double bond we are talking about. Does this compound contain exocyclic double bond? Yes. Then label it. This is only one ring, and now you look at this, carbonyl is outside the ring. It is always outside the ring. Carbonyl group is never inside the ring. It is always outside the ring, and therefore don't count the exocyclic double bond. Exocyclic double bond excluding carbonyl group, whatever this, if you look at this one, this is a exocyclic double bond. Remember, don't consider as this one. If you put hand over here, you will see clearly there is a double bond which is outside, only one exo. Don't consider as a carbonyl group, as an exocyclic. This is the enone system. Carbonyl group is involved in it, and therefore whatever carbon-carbon double bonds are there, that is to be considered as a exocyclic double bond, and therefore this is a exocyclic double bond. And now then how much nanometer to add? You should add 5 nanometer in it. And after that, let us see Homo annular system. Now Homo annular system, as usual, third point we are talking about here, Homo annular system. Let me draw one more example over here. Suppose we have this one, and then let me clean this one and try. I am trying to, this is a compound with double bond here, one double bond here, another double bond maybe here. So this is a compound. Now we are discussing, if you observe this structure carefully, what do you see? Look at here. Here there is a carbonyl group, single bond and double bond, and therefore this system is termed as enone system. Does this molecule has enone system? Yes, there is a enone system is present. Carbonyl group, single bond and double bond. This molecule has enone system. Now once enone system is there, there are the 3 base values. Then focus on that carbonyl group. That carbonyl group involved as a 6-membered ring, and therefore you should take base value is a 215 nanometer. That is clear to you. Now another one. What is that? We are talking about Homo annular system. Does this molecule contain Homo annular system? And as we know that yes, don't consider as this carbonyl group. It is always outside the ring, and therefore it is not included in the Homo annular system. Then look at here. Here carbon-carbon double bond, single bond and double bond, both the double bond are present in the same ring and they are in a conjugation, and therefore that type of the system are known as Homo annular system, and this is a Homo annular system is present over there. Homo annular system. And once the Homo annular system, how much to add? You should add 39 nanometer in it. 39 nanometer should be added in the base values. So in this way we have explained the Homo annular system over here. So this is Homo annular system. How much to add? 39 nanometer. Now fourth one is a extended conjugation. Fourth one is a extended conjugation. Extended conjugation. Extended conjugation, and if extended conjugation is present similar to as a diene system, there is no change if extra double bond is present. Remember, this is a enone system, one extra double bond is present over here. If you observe this structure carefully, you will find there is a one extra double bond is present, and therefore we can add here as a 30 nanometer in it. As usual are similar to as a diene system. Remember, this is the extended conjugation, add 30 nanometer in it. Now is a substituent. Look at here substituent. So substituent, now we are discussing here as a substituent, how to consider the substituent over here. So let me click this. Now the substituent. There are various substituents are present. Now let me clean over here. So we are discussing about the substituent present over here. Let's see here substituents. Substituents. Now here suppose substituents, if they are present at alpha position, then you should add in it as a 10 nanometer. Suppose as a substituent is a alkyl group. Alkyl means R. If present, then at alpha position you should add, let us see here. Here substituents, suppose A is a alkyl group. Alkyl group or ring residue. Alkyl or ring residue. Ring residue. How much to add? If they are present at alpha position, you should add 10 nanometer in it. So now remember, suppose here, if you consider here at alpha position there is one alkyl group, or what you can call it as a ring residue, which is present at alpha position. So you should add 10 nanometer in it. Now another one, if it is present at beta position. Look at, in this example you can clearly see there are two substituents, they are present at beta position, and if at beta position you should add 12 nanometer in it. Remember, this is a 12 nanometer in it, and if it is present at gamma or delta, if it is present at gamma or delta, you should add 18 nanometer in it. Remember, enone system is a somewhat difficult as compared to as a diene system. Diene system is a very plain system. We can use as a alkyl group. So, but in a enone system, you should remember alpha, beta, gamma and delta. If alpha is there, you can add 10 nanometer in it. If it is present at beta position, you can add as a 12 nanometer. And if they are present at alpha and delta position, that is I am talking about alkyl or the ring residue, you can add, these are the nanometer, 10 nanometer, 12 nanometer and the 18 nanometer. No need to remember these values. These values are given in the table and which are provided in the exam. If you have seen the question paper, previous question paper, you will find there are university providing these values in the question paper. At the back, at the end of the question paper, there may be as a 3 tables are generally provided. One has or one contain the IR tracing frequency. Table second contains the chemical shift values of NMR, and the third table contains the Dyne system values and the Unknown system values. So you should remember only the how much to take base values, and these that there are the certain rule which are made by Woodward and the Fisher, and so accordingly you can do it. Now suppose we have chlorine group, alpha position 15 nanometer, beta position 12 nano. If chlorine groups are present at alpha position, if Cl is present, if you consider here is a B, if it is present at alpha position, you should add 15 nanometer in it. If it is present at beta position, you should add 12 nanometer in it. If chlorine group is present at alpha position, you should add 15 nanometer in it. If it is present at beta position, you should add 12 nanometer in it. And suppose as OH or OR, suppose A, B, C, here OH or OR, if they are present at alpha position, how much to add? You should add, if it is present at alpha position, you add 35 nanometer in it. If it is present at beta position, you should add 30 nanometer in it. 30 nanometer in it. OH and OR, if OCOR is present, suppose as A, B, C, D, OCOR, that type of the group, if they are present at alpha, beta or gamma, you should add 60 nanometer in it. 60 nanometer in it. If O beta 75 nanometer, SR 85 nanometer, and NR 95 nanometer at beta position. If SR is there, then 85, NR is there, then 95 nanometer. Suppose ABCDE, SR is present at alpha position. We know that SR you can add, there is, I think alpha is not given, but at beta position, if beta position you should add 85 nanometer in it. If ABCDEF, then NR you should add beta position 95 nanometer at T.Y.B.Sc level. No need to remember all these things, they are given in the book. So now we are trying to solve the problem based on it. Let's begin with the example. From that we come to know that how we can solve the problem based on unknown system. Let us see the example. So how do we solve this example based on the unknown system? Let's see over here. First example is this one, which is like this. Let's see the problem over here. This is a structure which I have drawn over here, and here the carbonyl group, double bond, and one double bond I am putting over here. See the structure, that's it, and here are the methyl group. Now this is the simplest example and this is the first example. Now what is our first job to do, our first business to do? First, recognize, does this molecule contain diene system or enone system? If there is a carbonyl group, always remember it must be a enone system. If you observe at a first glance, you will observe there is a carbonyl group, and that carbonyl group present in the conjugation, single bond, double bond, single bond, double bond, means there is a diene system is present. You can mark it like this, means while solving this solution, it is a enone system. It is an enone system. It is an enone system. Now, when enone system is present, there are three basic values for enone system. Now, observe, this carbonyl group is attached to 6-membered ring, and therefore the base value should be here. Base value should be 215 nanometer. That's it. Now, another one, you follow the short form. E stand for exocyclic double bond, right? Then label the rings. It is a ring, it will be B ring, and it will be C ring. Now look at A ring. Does this has exocyclic? If you put here, there is a double bond. Don't consider as a carbonyl, as I already told you that. Here is a having one exo double bond. Now if you put hand on a B, you won't see any double bond outside the B ring. If you put hand on C, you won't see any double bond outside the C ring, and therefore how many exocyclic double bond you can observe here? There are only one exocyclic double bond. Exocyclic double bond. How many there? Only one. How much to add? 5 nanometer in it. Now H stand for Homo annular system. Does this molecule has Homo annular system? If you observe this structure carefully, you won't see the double bond in the ring. A containing only one double bond, B also containing as only one double bond. So there is a no two double bond present in the same ring, and therefore there is no Homo annular system. No need to write here. E stand for extended conjugation. Here you can write as a extended conjugation. Extended conjugation. If extended conjugation is there, look at this is a enone system. Now if you observe this carefully, what do you observe? There is a one extra double bond present in this system, and therefore how much to add? You should add 30 nanometer in it. 30 nanometer extended double bond is there. Now is moving toward as a substituent. Look at the substituent, and while substituting, then you label. Whenever there is a conjugation is there, means a double bond, single bond, double bond, single bond, double bond. At every junction, at every corner, there is a carbon atom, and they are termed. This is a carbonyl. Adjacent carbon atom is termed as alpha. Then next one beta, then next one gamma, then next one is a delta, up to the conjugated system. Whole conjugated system you should consider. Don't go beyond that. Only the conjugated system. And as we know that here, if at alpha position no methyl group, no substituent, so no need to write alpha whole. Beta, at beta position only hydrogen, you should add 0, so no need to write it. But at gamma position, if you see here, there is a one ring residue or the alkyl group present over there. So here you write it down like this. substituents. Here at a gamma position there is a one substituent, you add 18 nanometer in it. Now look at as a delta position, terminal one, there is also one substituent. So delta, how much to add? You add 18 nanometer, that's it, and then mark it like this. Then again write systematically maximum, and if you add here 8 and 8 16 and 10 are 26, so 6 comes here is a 2 3 4 5 6 7 8 and 2 as it is. So 286 nanometer, it is what we can call it as a 260 nanometer is the answer of this question. I think only one example is enough to understand this one. Let me solve one more example over here, second one, so that you can get some clarity over here. Now let's see here, there is a one double bond at this position, then this one C double bond O and CH3. This is a structure. Here are the two methyl group attached and not that position. Here not the top position, at the bottom position there will be a two methyl groups are attached. Now look at observe this structure carefully and find out what type of the system it is. It is a enone system. Look at here, carbonyl group, single bond and double bond, and therefore this type of the system is called as a enone system. Once you recognize that system, it is an enone system. Once it is a enone system, then how much is a base value? Base value should be, now look at here, base value, there are three base value depending upon that Z value. Here is a R means methyl group is here. So what is the base value for this? You should take 215 nanometer is a base value for it. And now after that, look at there is a ring. See here, E means exocyclic double bond. Does this compound contain exocyclic double bond? Put hand over here, outside there is no double bond, no need to write it. Homo annular, does this molecule contain homo annular system? No homo annular system. Another thing, what is that? Extended conjugation. Look at this is a enone system. No question of extra double bond present over here, so no need to write it. Now is a substituent. That's it. Substituents, and that the substituent at alpha position. Look at here. This is a carbonyl group, adjacent carbon atom. This is alpha, and look at here. There is a one substituent alpha 1. So you should add 10 nanometer. Look at here is a beta. This is alpha. This will be the beta. Only one substituent. So beta only 12 nanometer. So that's it. And then mark it like this. Lambda max, and then if you add, here is a 7, 1 2 3 3 and 2 as it is, so 230 nanometer is the answer for this. So in this way you have to calculate systematically. I think these are the enough example to understand enone system. Today we have considered only as a 2 example. The more example we will see tomorrow. Let's stop today here. Thank you. Have a nice day.